Good afternoon, everyone, and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP Span. My name is Stacy Ranella, and I'm the Editor-in-Chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or your junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeff Medeiros. Jeff is the architectural representative for AEP Span and is a licensed contractor who has been supporting architects in California for more than 20 years. Jeff can spec write, assist in detailed drawing, and aid in product selection or any aspect of the design build process from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. He provides architects with a full range of services from conception through bid. He holds various degrees, including Law and Society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up and torch applied, hot and cold process restoration coatings such as silicone urethanes and acrylic single ply roofing, and all forms of metal applications, including roof wall coping and soffit, as well as flashing trim. Jeff made the move to AEE Span over 6 years ago after spending years with a competitor and plans to stay on through retirement. In this webinar, Jeff will discuss metal roof systems, design, and installation considerations. Jeff, we appreciate you joining us today. Please take it away.
Hey, welcome everyone. Today we're going to talk through metal roof systems design and install considerations. I may jump around a little bit. Oh, and also this is the first time of the updated presentation, so we're going to make it through. So if I go off track a little bit, that's why. All right, here is the slide that we have to show you for the credits. Now that that's been shown, let's move on. Okay, so we're going to start talking about architectural roofing versus industrial roofing, okay? That's the main issue that I want to touch on now. So architectural and industrial. When you think of industrial, I want you to think of exposed fastener roof systems. When you think of architectural, I want you to think of concealed fastener roofing systems. We'll talk through some spec considerations and so on. So architectural roof, okay, that's your bling bling. I want to be visible. We're going to see things. It's super performance, life cycle costs, right? It's going to go forever. Beautiful profiles. Even if you take this to the walls, same thing with architectural wall systems, concealed fastener wall systems. The profiles and everything are just awesome, right? As compared to industrial, which is I'm going to refer to as exposed fastener. It's more functional. Okay, it's selected more for life cycle costs, and it comes in thinner gauges as well. So this is a slide that's a little new. It kind of lists some advantages and disadvantages. Given the fact that we've got 45 minutes, I'm going to kind of skip past this one so I can talk on other things. So exposed fastener panels, exposed fastener roofing systems, also industrial roofing systems. There's 3 things I want you to pay attention to, okay? Number 1, they are through fastened by definition. That means you run a fastener through the panel. It's a hole in the panel, right? They're nestable. They'll go back and forth. So these you can nest and alternate the profiles. What does that mean to you? They can ship on a pallet. So say, for example, you have a 10-foot length panel, you can stack them up, you can nest them back and forth. The third item is they rely on laps and sealant by definition, right? If you're going to lap it, you lap the profile. there's the lap, and there's sealant in there sometimes. So those are the three things for exposed fastener panels. They're tend to be more economical because let's be honest, I mean, you and I can get out there with a pizza and a 6-pack and we can put these things up. You can line them up, lap them, and run some fasteners through. Whereas concealed fastener is much more difficult and much more nuanced. They typically come in lighter gauges as well. So you can get 26, 28 gauge type panels. You can install them vertically, horizontally, roof, wall, whatever. It does not matter what the profile is. I don't care if it's a sine wave. I don't care if it's a box rib. I don't care if it's a trapezoidal or a diamond, whatever it is, corrugated, repeated profile, right? Okay. So as you can see in this bottom right-hand corner photo, the mastic and the laps, that's what we were talking about on how you install them. Okay. Mastic in the lap and the panels lap in order to be watertight. So typically exposed fastener panels can only be used under code and over conditioned space down to a 1/12 slope. All right, you can with solder or sealant in the laps. They can be used over 3/12 without that. Now, what you're thinking about now, hopefully, is that the fasteners running through are going to create a point of fixity. Okay, you are correct. That is a not a good which word am I looking for? It is a disadvantage to a through fastened profile. Is every point is pinned, which means the metal can't move. Right? Metal likes to dance. It likes to party. It likes to hang out. Metal moves. Steel's going to move 1/8 of an inch over a 10-foot length, and aluminum's going to move 1/4 of an inch over a 10-foot length. Okay, so when you pin these, when the fasteners go through, how do they move? Well, every single repetition is a predefined point of flexation. So it's going to flex. Okay. I want you to think of taking a piece of paper and putting a fold in it. And no matter where you push on that piece of paper on a flat desk, right, it's going to flex always on that point. So these are going to flex on the different profile corrugations as they repeat through. However, over time, one of the drawbacks, again, is these fasteners might back out. I think that slide was removed, so I'll talk on that real quick. When the fasteners back out, I want you to think of walking through your backyard and you look at your fence and there's a nail kind of backing out of your wood, right? The wood heats, expands and contracts, heats and shrinks as it gets wet or warm and so on. The nail is the same thing. It's going to heat up and it's going to back itself out over time. These fasteners can do the same thing. So a maintenance item with these exposed fastener roofing panels is going to be to go back and check these fasteners, right? Which could be hundreds or thousands, and make sure that they're not backed out. How do you fix it? You back it out, put an oversized in. So keep that in mind. That's one of the drawbacks to exposed fasteners. Okay, standing seam, concealed fastener, architectural. Everything's the opposite, right? They are not nestable. If you have a 16 or 12-inch wide panel, you can't fit a 12-inch or a 16-inch wide panel inside of that. They're the same width, right? So they're not nestable. The panels have to be flipped and positioned over. I will talk about the one instance where you can fit them in down the road. But concealed fastener panels, not exposed, not nestable, and they don't rely on laps and sealant really in the traditional term. They rely on an interlocking standing seam leg, okay? Let me see, bearing plate with rigid insulation. I think there's a bearing plate one coming up. Again, thanks for working with me on this updated presentation. I'll talk in the bearing plate real quick. So rigid insulation isn't that rigid, right? It has a compressive strength of about 25 to 35 PSI, depending on what you move with. Typically, it's about 25 if you move with like an ISO-based product. So if you and I are up on that roof walking around, we're going to leave footprints in the snow, okay, in the ISO. So when you have a clip like this that has a small footprint and the fasteners go through under tension, that clip's footprint is not going to be distributed over a wide area. So what a bearing plate does is it's a plate that the clip slides into that allows for a larger surface area, like a snowshoe, over like a not strong compressive strength substrate like polyiso. So yes, you can put an exterior gyp over, like a dense deck prime, secure rock, or similar, especially if you need a fire rating over combustible deck, and that has a compressive strength. Oh goodness, let me think back. Is it 800 or 900? I think it's 800 psi. So when you have a exterior gyp on top of the ISO fastened through, you don't need the bearing plates. But when you're over something that's not as strong in the compressive strength, a bearing plate's needed. Again, a snowshoe, think of that for that clip. So there's a couple different configurations here. We'll start in the upper left corner. This is your snap lock, male to female. It's one of the most common roofing systems available. Female leg entraps the male leg. There's sealant in the leg. Click and lock, push and lock, right? Moving over to the middle and the right, there's your mechanically seamed panels. There's different variations of this. There's T-seams, there's bulb seams. But when you mechanically seam something, you're wrapping either the batten or the panels, adjacent panel leg together, and you run a mechanical seamer down the length of the panel that seams it all up nice and tight. The narrow batten seam and the wide batten seam on the bottom, these are your traditional standing seam panels. So when you think of this, I want to draw your attention to the wide batten seam. So this is just two 90s that go up, right? Even with the narrow batten, two 90s that go up with a clip in the middle. So there's no entrapment of the adjacent leg. There's a little gap in between that narrow batten seam. So let's blow that up. Let's zoom in and magnify that out. And let's pay attention to the wide batten seam. There's that gap where that fastener goes through. So the batten is the only thing that's protecting that layer from water getting through, right? So the thing is with these systems is you need to install them on a 3-12 slope or greater. Because again, even though with the narrow batten, it's real close, there is that potential for moisture and water to get through. So standing seam legs, again, attach the substrate and trap the vertical panel legs. This is an architectural. And the clips can be one piece or two piece. I'll touch on that in a second. Moving on. Okay, one piece clips. One piece clips allow for unlimited thermal movement, okay? Whether it's this type of a snap or a T-seam or a bulb seam, the clip is fastened and the entire panel can expand, okay? Now, again, keep in mind, metal likes to move, it likes to party, it likes to dance, right? Steel, 1/8 of an inch over a 10-foot stick. Aluminum is 1/4 of an inch over a 10-foot stick. This is some pretty sizable movements. So two-piece clips allow for certain mechanically seamed panels to float back and forth, plus or minus 1 inch. So you might have some alarm bells going off on your head about maximum lengths, and I'll touch on that in a second. But one piece versus two piece, unlimited thermal movement versus a limited thermal movement. There's my bearing plate. There it is. That's what I was talking about. Okay, it's pre-punched. The clip slides in, and it acts as that snowshoe to distribute that load under tension. Otherwise, if you install over polyiso directly, it'll sink in, fasteners will become loose, and your roof is compromised. Again, thank you everyone for making it through on this newly updated one. I'm not 100% in line with where everything is yet. Okay, continuous length standing seam panels. You have a client that has a shed roof over a gym, and they want continuous length panels, okay? It's 150 foot long. Great. We can do that. A lot of manufacturers can do continuous length panels at 150 feet, but you need to be aware of the limitations. And here's what I mean by that. Continuous length panel, you're going to need to do on-site roll forming because we can't truck in a 150 foot long panel. There's no way, right? On-site roll forming. Well, if the panel's 150 foot long, you now need a 150 foot long runout space in order to roll form that panel. Oh, and in addition to that, you're going to need one person per 10 foot length of that panel to move it off of the rollout table onto the storage area. That's a lot of labor. And that's prevailing wage oftentimes if it's that large of a roof, right? And that's metalworking prevailing wage. That is a big increase. All right, cool. Now you have it rolled and on site, and you sent in the coil and you hired all the people to move it. How do you get it on the roof? Well, You need a crane. Awesome. You need a crane operator. Have you seen how much they're paid? I should have gone into that profession. They make as much as heart surgeons in some instances, okay? Crane operator. You now need site control, site access. You need a spreader bar. A spreader bar goes from 2 pick points to 4 pick points to 2, 4, 6, 8 pick points, and it lifts that huge length panel so it won't bow when you lift it. There's the spreader bar rental cost. Now you need perfect weather conditions, which I'm sure everyone has, right? Seattle has it all the time. There's no snow, there's no wind, there's nothing going on. You need perfect weather conditions because if that panel spins while you're lifting it as your subcontractor, they're not out a 10-foot or a 20-foot long panel. They're out a 150-foot long panel. That's expensive. Then you lift it onto the roof and there's the installation. So that's the cost that can be associated with on-site roll form. You can do it, but be aware of the limitations on that. So the other option is to go with a lapse panel, which I'll touch on in one bit. So again, you can do it. You can do it curved, arched, whatever, but be aware of those installation considerations. So if you're going to do long length panels, make sure you're dealing with someone who is a quality supplier. So the testing applies to that panel. A lot of roll formers are on the market for 30 to 40 grand, and 2 guys in a truck that do cabinets one week, painting the next, can do metal roofing. Well, make sure that testing applies. It's a UL certified roll former. Insurance is all there. Don't screw around with the 2 guys in a truck that can roll form a panel for half the cost, okay? There's other things that come into that besides the overall cost. There's a lot that comes into that. Deal with a quality supplier whose testing will apply. All right, what's this one? Substrates. Okay, so if you think metal will not follow its substrate, you are sorely mistaken. It will. We can install over any substrate, right? Wood sheathing, metal deck, concrete, open purlin, whatever, right? But it will follow the substrate. So this slide's just here for these 2 pictures. Really, it's pay attention to what's below because they will follow it. Okay, underlayment. Yes, okay. So one of my favorite pictures is coming up soon, I think. Underlayment's going to depend on certain applications, but for 99.9, what you're going to want to move with is a high temperature, self-adhering, non-sanded. A lot of times they'll sand asphaltic rolls and underlayments and 2-ply modifieds and so on so they don't stick together. You don't want the sand on that roll because the metal will act like sandpaper, right? It'll when it moves, it's going to sand the back of that panel. So a non-sanded, high temperature, self-adhering, self-healing, so it heals around those screws. This is what you should move with. They are typically 40 mil, 250 mil. There's some in there that are 30, but it's not 30-pound felt. All right, Jeff, why do you say don't use 30-pound felt? Well, oh, the picture's not coming up yet. Darn. So 30 mil peel and stick. I talked through all this. Let's see if the picture's coming up next. Ah, there it is. Yes, I love it. High temperature underlayment. 30-pound felt can reemulsify under temperature, okay? Then it leaks like this. This is such a great picture. I love disaster pictures like this. So if you have some after this is done, send them my way. I keep a file on these. It can reemulsify 30-pound felt and then leak down the sides of your building. Most high temperature metal underlayments are rated to 200 to 250 degrees. They will not reemulsify. This will. Can you imagine if this wasn't coping and it didn't go on the inside of the structure? What if it was down your nice new metal roof, down the outside of your new building? Oh, goodness. Not good. Use the appropriate underlayment. Okay. This one, exposed fastener roof panels. Again, I talked on this. They can use the lighter gauges all the way through the heavier gauges. And then standing seam roofing panels, architectural ones concealed, are typically 22, 24, and sometimes 20. You can do them in any metal you want. Aluminum, steel, galvanized, copper, stainless, whatever. Okay, Here's our first question break. Am I doing good on time? Doing okay. All right.
Okay, thanks, Jeff. We have some questions coming in here. What is the longest panel you can truck in?
Ooh, that is a loaded question. Okay, so for example, Coronado Island in San Diego was one of our recent debacles. The trucking length into Coronado Island, I want to say, is an 80-foot length with a chase truck and a flag car with an extended flat, and it's because of the turns. So there's certain areas like up in the mountains where you just can't get panels in. So that question is going to be, there's a lot of factors that go in from can you make the turn with a longer length truck to can you use a chase car in your area? But generally speaking, it is going to be 75 to 80 feet under perfect conditions.
Okay, thank you. Next question. Do you have any recommendations for confirming the gauge of metal in the field? I've seen sheet metal gauges, but due to the coatings, thickness can vary.
This is correct. This is absolutely correct. And it can vary depending on paint systems. There's different paint systems. That's our next section, and different thicknesses. If you have a marine gauge, a marine paint system, it will be thicker. That's a solid question. Good job on that. There are metal gauges that you can use for gauge finders, but you are correct. That paint system may impact the gauge of that metal. Typically speaking, you're going to want to measure it unpainted. I don't really have a good answer for that outside of a contractor with their gauge measurement tool.
Okay, let's go to the next one. Is it possible to unseam damaged standing seam panels in the middle of the field for repair?
The questions today are on point. Good job, team. All right. Yes, it is with certain panels. So there's directional and not directional panels. And I want to take a second to answer this because that was awesome. Okay. The male-female interlocking panels, you have to start at one end because it's going to entrap the other leg and you're going to move across the roof, right? To do those, say that you get a baseball dent or heaven forbid a hole, or this is no joke, I've seen bullet holes coming down in panel roofs. You have to pull off every panel to the side to get to that one. So hope it's towards the end, right? The other way you can do this is with a non-directional panel. That is with one of those, the ones I talked about where the panels come in and then they turn up in the traditional 90, or the T-seam type panel that has a batten. You can slice that, cut that batten off, and then you can replace the exact panel. So it depends on what panel that you go with, but yes, you can replace them. Depending on panel selection, it could be more of a pain in the rear, as opposed to one that has a batten that you can cut and pull off. Solid question.
Okay, we will get back to the presentation and take some more questions in a bit. Back to you,
All
Jeff.
right. Okay, so you see this picture right here. This was brand new insertion of this photo. I used to say, take a roll of toilet paper, right? Now make it metal. Now turn it eye to the sky and then make it this big around and hug it. That's what a coil looks like. So I'm sad that I can't say that anymore, but this is what a coil looks like, okay? So aluminum zinc is a galvalume zinc loom, right? Okay, same thing. Tissues Kleenex, same thing. It's a 55-45 aluminum zinc. The aluminum provides the corrosion protection and the zinc provides the sacrificial layer, right? So zinc aluminum galvalume as opposed to galvanized. So zinc aluminum galvalume is the coating that comes on when the coil goes in and it runs through. This is what we call our bare steel or our zinc aluminum galvalume steel, okay? Okay, this is what it looks like. Hot dip sheets are available. This coating, aluminum, the galvalume zinc aluminum, is warranted for up to 25 years on your substrate. Once again, 25-year warranty with a substrate. Zinc-coated steel, the G60, G90, or galvanized, isn't warrantable. Pay attention to this. Not all manufacturers are the same, okay? If there's a 30-cent price difference between two different panels from manufacturers that have the exact same panel offering, why is that one cheaper? Check the paint system and check the substrate. Is the substrate aluminum, galvalume zinc aluminum, or is it galvanized? A lot of manufacturers play the galvanized route. No substrate warranty. Galvalume zinc aluminum has one. Okay, so let's talk paint real quick. Let's start with polyester. Polyester is what a lot of manufacturers use on the bottom side of their panel because it's not exposed. This is also sometimes paint systems that you can get flat sheet from suppliers. I'm going to go off track here real quick. If you're specifying something, make sure you specify that all sheet metal flashing and trim shall be sourced from the same manufacturer as the metal panels in order to, number one, maintain an exact color match paint system and paint system, and number two, a congruent warranty, because it'll be different. So again, not all paints and panels are the same. One step up, SMPs. SMPs are used on light gauge products. Awesome paint system, okay? Think of a piece of cardboard versus a piece of card stock versus your standard white piece of paper that you're going to print on your printer on, okay? That white piece of paper is going to move, right? That's your light gauge metals. They're going to move and flex a lot more. If we're carrying one from a truck to the project, it might bow and flex a lot more. That's 26, 28 gauge. Your card stock is going to be your 24, 22, and then your 18, 16 gauge is your cardboard, right? So it's going to vary. SMPs are used on the ones that move because it's less brittle. Then you have your top of the line Kleiner system, paint system, your Kleiner 500, your PVDF, your polyvinyl fluoride, whatever you want to call it, Duratec 5000, Duratec 500, all the same thing, Kleiner. Okay. SMP and polyester have their purpose, but they don't have the performance characteristics and chalk fade values that Kleiner paint's going to have. Okay. Up to 40-year warranty on Kleiner products now. That's in addition to your substrate. So when you pair Kleiner paint with your substrate, zinc aluminum, galvalume, awesome. You have a 25-year substrate warranty and 40-year paint finish warranty. Awesome. Now here's the question of the paint thicknesses comes into play here, okay? Because as you move up that chain, the paint gets thicker, right? And then if you move to the saltwater environments, again, aluminum's not always the best choice here, okay? You can get a Kynar-based marine paint system with a thicker base and a thicker top coat, and then a gloss over the top, or a top coat also if you want to go for a 20-year range. So again, I'm going to go off track here real quick. We can warrant with a marine paint system steel directly over a salt body of water. I'm talking like a restaurant or a fish house on a pier over a salt body of water. Aluminum may not be the best consideration in every instance, okay? Aluminum in sheet form, because I don't want to get all the materials people up in a tizzy. In sheet form, rolled form, aluminum doesn't have the performance characteristics of steel, okay? Think of your grandfather's old school truck, right? You're going to go shopping and a shopping cart hits it and it dings the door. We'll go home, we'll pull off the interior door handle, we'll hammer that thing out and it's good to go. That's your steel. Do that with a modern car. Okay? Aluminum ain't going to happen. So you're also going to need, it has a memory, right? Steel has a memory where aluminum doesn't. Now, also the performance, if you're going to use aluminum in panels to hit your wind uplift, you might need up to double the amount of clips and fasteners to keep it in place because it doesn't have the performance steel does. So if you're doing a salt shed, okay, let's use aluminum, right? If you're doing an animal fat rendering plant or a paper mill, okay, let's use aluminum. But talk to me about which metal to choose, because aluminum's not always the best choice. Anyway, jumping back on track. Here's how it comes in. The base steel comes in, it gets run through a variety of tanks. I'm not going to jump into that now in the interest of time, to either get galvanized or zinc aluminum galvalume. Then your primer coats go on, and then your top coats go on. Again, on the bottom of the panel, it's in white or off-white polyester. The top is typically Kleiner. Okay, when you're specifying, I talked about this, when you're specifying paint, check the paint language because not all paints are equal. I'm going to skip on this because we have 45 minutes, okay? Sealants. Two types of sealants, really, okay? Those that like the sun, those that don't like this. What just happened there? Balloons just went over me. That's interesting. Okay. I'm on my new iMac, so maybe that's one of those hand gestures. That was cool. My apologies. I'm learning something new. Um, those that like the sun and those that don't like the sun, okay? Non-curing butyl can be tube applied. It can be mastic based. It can be butyl tape based. This is what you put in labs. It doesn't like to see the sun. It doesn't dry out, break down, provided it's not exposed to UV. Okay. Your other option, oh, this is the butyl tape and so on, where continuous beads are needed. You can see it right there, right? Again, all non-exposed applications. The butyl tape does not like sunlight. They're the vampires of the sealant world, okay? So again, do not let it be exposed to sunlight. There it is, single component urethanes. This used to be on a different slide. Single component urethanes are the ones that like to see the sun. Okay, these are used for like when you integrate with a non-metal surface, block, concrete, stucco, wood, things of that nature. These can also be tinted. So those that don't like the sun, those that like the sun. Okay? All right. Let me touch base. What's this one? Oh, ASTM E5092. Real quick. Okay, so we're going to go off track again. ASTM testing pushes to ultimate failure. UL testing does not. Here's what I mean by that. You are going into surgery, okay? Do you want the doctor, your surgeon, to be a pass-fail? That's UL. That's your realtor's exam. Okay, did you get a 70% plus? Okay, you can operate on me. No. UL's pass-fail. ASTM testing, for ASTM E5092 for wind and air and water, the 1680, 1646, these push to ultimate failure. Okay, that's your ranked surgeon. I went to school and I took my boards and I was number one in my class and I passed with this score up here. I want that person to cut me open, not the pass fail, right? So think of it that way, UL versus ASTM. Metal roofing, it's recyclable. In the interest of time, we'll be moving on. Okay, cool metal roofing. I get this question a lot. What is cool Regal blue versus Regal blue? Okay, this is how I think of it. I want you to picture Tinkerbell. Yes, Tinkerbell, okay? And her magic fairy dust. What cool means is a chemist was able to make magic fairy dust that they sprinkled into the paint system like Tinkerbell. It doesn't show up, but it's infrared reflective pigments, not pigmentized, doesn't change that paint color. It drops SRI. It is literally magic fairy dust that I don't understand how it works. Some chemist that's way more brilliant than me did this. Cool Regal blue and Regal blue are the same color, but cool Regal blue will have low SRI values. Again, it's the magic fairy dust sprinkled into the paint. Okay, we're going to skip this because in terms of time. All right. You want to attach stuff to your roof. Okay, we want to put up PV. We want to put up a catwalk. We want to put up signage. We want to put up snow retention. We want to put up heat melt, snow melt systems, right? Like a Byland cable system. Use clamps. These clamps clamp to the standing seam with a set screw, and they don't put holes in the roof. You can put whatever you want on it. I think there's another slide on this. Oh, there you go. Okay. Space it out. You can do your PV subframe. You can put signage on it. You can do everything except fall protection. Do not ever attach fall protection to a clamp, because the fall protection tests that to the clamp, not the clamp to the roof. So again, fall protection should be tied to your building structure via davit, etc. or D-ring, not to your roof that is engineered for wind uplift, not for someone like me, a 6'2", 205-pound person with a tool belt to slide off the roof and put that force on it. The forces that come into contact there are off the chart. We can talk through this later if you want, but do not tie fall protection to these clamps. Anything else is good. That's PV on this slide, and then it shows how it's going down on this slide. Dissimilar metals, come on, right? Think back to your materials classes. Don't let your copper wiring touch your roofing system. These clamp systems aren't going to avoid a warranty, but seam damage as a result, it won't be covered. There is a torque that must be tied to from the clamp manufacturer. We work in conjunction with a multitude of them, so it's very simple to figure this out. Now, for those of you that are thinking I'm going to go off track again, wind uplift. Jeff, we just put this huge PV system down. It looks like this. It's like a big wing on the roof. Will that add to your wind uplift? Yeah, it will, but keep this in mind. Every single one of those standing seams has a 2-foot or 4-foot on center clamp that is squeezing it tighter. So in almost every situation, the additional wind uplift is negated by the additional clamping force on that seam from that clip. It's very rare that it goes above or it's not negated entirely. There's your PV. Questions 2. We still on time? Oh, we're doing good. Okay.
Okay, we have a lot of questions coming in here.
Okay.
Other than gauge, is there anything to help prevent hail damage? Would a 1/4-inch vent mesh layer used for all zinc panels on top of the 40 mil underlayment help or make it worse?
There's a lot to unpack there. So there's a couple different things that come in with these metal panels, okay? Number one is this panel raised off the deck? With a lot of T-seam and bulb seam systems, the panel's raised by 3/8 of an inch. For a lot of mechanically seamed systems that aren't T-seam or bulb seam, the panel is also raised with a standard clip. If it is raised, there's that little gap, right? Nothing's going to come into play. If the panel is sitting on the surface and you use the pan head fasteners on that clip, and the actual panel, if you zoom in, is going to bow a little bit to the middle and rest on that surface, it's still going to move, okay? I would not put anything under that panel that could damage the underside of it. I would rely more on your compressive strength underneath, which would be your exterior jip, in order to resist hail damage. That is a very nuanced question. The questions there are on point. Good job, team. I have seen some hail damage, and man, I don't think it would help. I think it would be better to leave that panel sit straight on the substrate, and I would put a solid substrate underneath it. And then go with a higher gauge, of course. Yeah.
Okay, back to the topic of repair in the field. If repair of metal roofing is possible in the field, what amount or percentage of overage do you recommend for attic stock?
For added stock. So what you're talking about here is when you order panels, you want to order additional panels to be roll formed that the client is going to keep just in case something happens. Man, I've never been asked that before. Well, I suppose it would would be determined by the length of those panels and where you could store them, if that's what you're after. I would leave that to your discretion. I don't have a solid answer for that. If it's near an area that is often impacted, I would order more than not. What I mean by that is schools, because baseballs, skateboarders, yes, skateboarders love to go down metal panels. So if it's in an area or on a structure like that, like an occupancy type such as that, I would order more than is compared to like a library. Also, steep slope versus a lower slope. The steeper it is, the less damage is likely as opposed to a low slope. That's the best answer I can give for you. I'd leave that up to you. Typically, contractors order 10 or 15% overage.
Another related question, can standing seam panels be patched akin to filling a dent or hole with Bondo on sheet metal?
Yes, they can. So yes, akin to filling a hole with Bondo. No, the typical way to go about it is going to be to cut a circular patch that's larger than the impact zone, and then set that in mastic, and then pop rivet that on. But again, the pop rivets can only go through the top layer of the panel. They can't go into the substrate because the panel has to be able to move. I have seen that done.
Okay, one more quick one. Is there a shortage on Kynar?
Ah, on point. Okay, man, we're gonna open this up. Well done, whoever this was. Yes, there is. Here's why. EVs are a big rage, right? In EVs use the PVDF in the separator of their batteries between negative and positive, if that makes sense. Okay, so Elon Musk and Ford and Toyota have a lot more buying power than the paint industry, and they're buying a ton of this to put into the EV batteries. Okay, so yes, there is a shortage that we're anticipating, and there could be an issue coming up because if things continue down the same path where these same batteries are used, and that is the separator material in that battery, paint buyers can't compete with Tesla and Ford, right? So they're going to lose out. So the cost of that is going to go up. It will be reflected in the cost of the paint. There's 3 different solutions to this. Number one, the EV industry finds a better battery and they move away from it. And all of a sudden it's like, oh, wow, what do we have with all this extra material? Sell it to the paint industry because we love it. It's awesome. That's the first thing, which that's the way I'm hoping it's going to go. Option 2 is you pay the additional cost. It's going to come out and it could go up. There's the balloons again. It's the 2 fingers. I'm sorry. That must be the gesture. Option 3 is the paint systems that are used by the manufacturers are going to move away from Kynar towards a more SMP based paint. You're going to see this in the lighter colors to begin with because chalk and fade is not easily as perceived, or they can develop a new compound on their end. Be aware of this though. This could potentially happen. There is a Kynar shortage. It's not extreme. It could go the way of the EV, or it could go the way of the paint systems finding something out. But all this is in process right now. And if nothing happens, the batteries stay the same. They don't improve. And the paint systems aren't figured out on the paint systems end, like PPG and what is it, Sherwin-Williams and so on. It will go up in cost. You will see a move to more SMPs. Solid question.
Okay, we'll take some more questions in a little while, and let's get back to your presentation, Jeff.
All righty. How much more time do we have? Oh, goodness. I meant like almost at the thing. We're going to go through this real quick. Okay. Wind uplift, water and infiltration, expansion and contraction is what we're going to talk about now. If you can hear my wind, yes. This is the essential design factor in a roof. Wind blows roofs off. Again, we're going to move through this. Okay. Wind uplift, your ASC 7 calcs, your exposure categories, wind speed, building heights, roof slopes, gauge of the product, width of the product, pan, and so on, all come into play. We can do preliminary wind uplift calcs for your spacing for your clips and fasteners, and so on. Reach out to me if you need help on this. Okay, we're going to skip by these. Static air pressure, again, UL. Pass, fail, ASTM, push to failure. Think of the doctor that passes versus the doctor that's ranked. ASTM 1646 and E1680 is your air and water and so on. That's testing. Okay, this is the one that I wanted to skip to. ASTM E2140. This is when panels are lapped. Okay, we're going to move on real quick. I'm going to skip this in interest of time, skip this in interest of time, skip this, skip this. Okay. Think of that 2140 test where the panels are lapped. There's 3 different ways to accommodate for thermal movement. High end of the panel, middle of the panel, end of the panel. Pretty self-explanatory, right? 90% plus of your installations, you will pin the panel at the panel head. For drag load, it will expand down slope. That is your traditional ridge, okay? All right. This is where all this comes in. Say that you don't want to go through the whole process of on-site roll forming and you don't want that cost. but you have that 150-foot long shed roof building. You can pin it in the middle with a fixed clip, have it expand upslope, have it expand downslope. That 2140 test where the lap comes in, that's a pressure head test. You lap that test is you lap the panel, flood it with 12 inches of water, pressurize it from below, and nothing can leak through, right? So laps are solid. Don't worry about lapped panels. Okay. If a manufacturer is going to warrant it for 10, 15, 20, sometimes 30 years with a lap panel, the testing's solid. The ASTM testing's there. Okay. If you pin it in the middle, expand upslope, expand downslope, now you can truck your panels in. You can move them onto the roof with 8 people, maybe not even a crane. No on-site roll forming. None of that cost comes in. You can lap it in the middle and still hit that same panel run. Moving on. This is a detail of a EVE condition where it expands downslope around a cleat and expands and contracts to keep that panel hooked. I got like 5 minutes, so we're going to go. Incorrect, correct. All right. I know everyone here loves this detail, right? Where it goes from a roof to a wall. It creates a point of fixity when it turns down the EVE line. You cannot pin it at the top now because it will thermally lock the panel. It'll fight against itself. Remember, metal wants to move, it wants to dance. It'll fight against itself because it's pinned at this section. You cut the panel ribs, fold it over, and you put those kneecaps on, right? This is what it looks like. I don't care if it's mansard or if it goes all the way down the wall or whatever. It creates a point of fixity. Because of that, no, not quite there. Oh, don't use these in snow. Okay, freeze, thaw, freeze, thaw, freeze, thaw, pop. Got it. If you have it turned down the wall, you have to use a floating ridge condition. Here is one way to detail this. You see the step in that ridge that goes, that step that goes up? That acts as a spring. So when the panels expand up slope, it does this. Okay. If you have a roof to wall condition where the panel comes from the top of the ridge to the wall, cut the ribs and turns down the wall, you must use a floating ridge in order for the panel to expand upslope. I wrote an article on this that I believe they have. So if you're interested, I can send that to you. Again, the drag fasteners cannot penetrate the substrate in this condition because the panel won't be able to move. It has to be able to move upslope. That entire panel moves with that Z, and that ridge flexes. Okay. This is, what is this? This is a fixed panel. There's a better idea. Okay. That 150-foot long run, 75, 75. I said earlier, you can't fit a 16-inch wide panel inside of a 16-inch wide panel. And you're going, well, how do you lap it then, Jeff? Good question. You swedge it. You see these marks on this panel that look like an airplane canopy almost, where it's bulbous and it goes back and it trims down. It's a tool that does this. And it squishes the very far end of that panel just enough so you can slide, depending on manufacturer, 8, 12, or 16 inches inside the other panel and do that lapped condition. Always stagger your panel slaps. It's good form. It's more aesthetically pleasing. And if you have a failure along one, it's not going to rupture the entire line because they're staggered. Swedging is how you fit them in, which is why you can't ship them like this because you don't swedge the panel until on site. That's what I'm looking for right here. Fixed panel clip in the middle. It's going to grab it. You're going to have your fixed panel lap with your swedge marks as identified by that little airplane canopy. There's mastic in there. Fasteners run through, and then expands upslope, expands downslope. That's how you avoid on-site roll forming. Okay, also, you can do this at the apex of a barrel or radius application to fix that and let it expand down either side. Fixed in the middle, going down either side. Blasting through this. We're going to make our time, everyone. Drag load. This is why you want to put drag fasteners in your panels at the ridge on your 90% of installs plus, right? Donner Pass. Did a project there once. I want to say CHP is what it was. The drag load at Donner, which I'm sure you've heard of because of the Donner party, same place, right? Snow load there was off the chart. It had something like 40 something plus fasteners for each panel. Ridiculous. make sure you do your drag load. Okay. What is this? Cold climate design. Okay, so again, snow's going to move down your roof. This is damaged. It hit a penetration and totally short off. You will want as steep as a roof as possible in heavy snowfall areas. Also, cold roof designs, you can also ventilate the panel from below, right? I'm not going to dive into this too much, but here's a solution of how to get around that. You can incorporate ice melts, creative solutions like this using your clamps that you can put on these standing seams, and so on. So snow retention is possible. Just keep that in mind. But again, it's based on your site-specific dead loading. Okay, you can use your snow retention devices with the clamps I talked about earlier. Here's a photo of that. We're going to move on. Wide valleys, okay? In certain areas with heavy rainfall or heavy snow load, you want to use wide valleys. And what I mean by that is I want you to think of a freeway where people are joining on, okay? The valley is the freeway. The panel at the very top of that panel run, you only have moisture or snow collection from one panel width. Then it joins the freeway. The next panel down merges traffic into that panel above it. The third panel down is merging on to 2 panels. The fourth panel down is moving on to 3 panels, etc. The further down you get, the more traffic is hitting this valley, for lack of a better term, right? Think of it with water. You're going to have water hitting and pulling under and doing all kinds of crazy stuff, and capillary action getting sucked underneath. Make the valley wider to accommodate for that runoff in heavy areas like this, because it is like traffic. The further down you go, the more traffic the runoff and snow is going to encounter. Accommodate for that. Okay, pipe boot details. I want to touch on this because this is often not done correctly. The pipe stays stationary. The metal moves around the pipe. It expands and contracts. That means the hole that is cut must be large enough to accommodate this movement. The pipe boot is a slinky. The top part stays with the pipe. The bottom part moves with the panel. So all pipe boot is a slinky. It moves back and forth. Okay? You do not fasten the pipe boot through the panel into the substrate. Why? Because then you thermally lock that panel. This is a huge no-no. If you fasten those fasteners through the panel into anything besides the panel, it just locked it. Okay, and what does it do? It does that. Rips it off. Pipe boots are slinkies that go around the pipes. Maybe a plumbing pipe or something can move back and forth, or a generator, or whatever, right? It can shake, but it moves with the panel below it. Okay, the panel below must have a hole large enough to accommodate the room for the pipe movement. Do not fix the boot to the substrate. Fix it only to the panel to allow for thermal movement. Pipe penetration should always be in the center of a panel run, so there's room for moisture to run, water to run around each side. If it's off to one side, okay, but it has to be able to get around. If you have more than one panel width, use a home plate detail. A home plate detail is the correct way to do a pipe in the middle of a rib or off to the side. Don't do that. Do that. Okay? Moving on. Anything over 2 panel widths, put it on a curve. Rule of thumb. Okay? Pipe penetration is 1 with your slinky in 1 panel. The second item is the home plate detail. Third is a curve. 1 panel, 2 panels, 3 panels. Pipe penetration, home plate, curve. You can mount anything you want on a curve. Skylights, solar tubes, HVAC, ventilators, whatever, right? Curve mounted. I made it. We made it. We're over time by a little bit, but we made it. All right, let's do some questions.
Perfect timing. Okay, a couple more questions. Do the clamps attaching items to the roof restrict movement of the roof panels?
It does not, because the clamps are on top of the seam and they move with the seam. So the entire thing's going to move as one uniform sheet. However,
Okay.
good question, don't tie anything to a fixed point up top, right? It has to be able to move. And there's, at this point, millions of installations like this. So it's a very solid system.
Okay, let's talk about residential. For residential designs, how can I specify extra wide ridge caps? Do you make them custom?
Got it. So extra wide battens, ridge caps, excuse me, not battens, ridge caps. Yes. Okay, so two things here. Number one, yes, a lot of manufacturers do manufacture ridge caps on their own as part of the system. However, you will pay for it. It's an additional cost because the manufacturer is going to take their metal workers and they're going to take the sheet and bend and break it and form it. But then it has to be protected and shipped to your site. The better way to handle this is to go with flat stock. Again, I talked about this. All sheet metal flashing and trim shall be sourced from flat stock from the same manufacturer as metal panels for the warranty and the paint, right? Let your sub do this, man. Ridges are easy to make. You ship flat sheet to the site. They can cut it, bend and break it, and put it up there, no problem. You're going to save on the overall cost, the packaging, and so on, getting it to the site. And if your measurement is wrong, even by a quarter inch, you're up a creek with no paddle. Let them site measure it and fabricate the ridge on site. Wide ridges or larger ridges are very, very common. If you have a sheet that's 4 foot by 10 foot in length, which is a typical metal sheet, that ridge cap, I mean, it could technically be 2 or 3 feet, right? Because after you hem it and all that, you're limited by the width of that sheet. But doing a 16-inch wide ridge or so on is very, very common. And let your metal sub do that, unless you want to pay more in order from a manufacturer.
Is there any pros or cons between using a wide or narrow batten seam?
Okay, so that depends on what panel that you're using. So if you're using the traditional 1900s type style panel that just has 290s that turn up and the batten goes over the top, there is a serious pro and con because the wider space you have, that is an exposed substrate. Granted, you're using a high temperature ice and water shield type underlayment now that you've seen my picture of the 30-pound felt remulsifying, but you will have that gap with that batten. So narrow battens are generally more watertight because the space is closer together as opposed to wide battens. However, you can also do a standing seam like the interlocking male-female one, and you can, after it interlocks, you can put a decorative wide batten over the top. I know that we manufacture those in-house. So if you want that wide batten look over a lower slope, because again, those 90 bends are limited to 3 and 12 or higher. You have a 2 and 12 system, but you want that wide batten look, or you want it on the walls, for crying out loud. Standing seam on the walls looks fantastic, right? Put it on the walls, you can put a decorative wider batten over the top of that seam and solve all of your problems. Because even if moisture gets underneath that batten, we don't care because it's an encapsulated standing seam leg. So yes.
Okay, I've heard it's better and possible to fasten an exposed fastener roof panel through the high point of the corrugation to minimize leaking potential. What's your take on this?
My take is that is correct. And what I mean by that is water will always find a low point, right? If you have a roof leak in a commercial building, half the time it's from the HVAC, right? The water finds a low point in the HVAC and leaks out. When you have a corrugation, let's take a sine wave, for example, okay? And it rains. The water will go from the top of the sine wave and find the trough. It will then run down that flute. So putting your fasteners through the high point on like a sine wave exposed fastener will minimize the water being saturated around that fastener. It'll run to the low point. There are instances where you cannot do this. In that case, I understand, but in terms of the question, yes, it does. It is more beneficial to fasten at the high, the peak of the corrugation versus the trough where all your water runoff is going to take place.
Okay, let's squeeze one last question in here. Is there a recommendation for type of seam for standing seam roof that works best for PV clamp?
So there are quite a few manufacturers of these PV clamps, and they manufacture different clamps for every different roof system. I would do a search because on one of the main manufacturers of these clamps, can I say trade names or no? I can't, right? Can I? Okay. So like if you go to s5.com, which manufactures these, they're one of them. I guess the presentation's done, so I can say trade names. S5, S-5 has clamps, and you can do a drop-down menu of what roofing system from what manufacturer. They cover every single system out there, including corrugated. They have a Coru bracket. You can mount a sign on the corrugated, right? They cover everything. So the world is your oyster.
Okay, thank you, Jeff, and thanks to everyone who joined us today. That's all the time we have. If you need to reach out with any additional questions, Jeff's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered within a week. Once again, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks, everyone. Thanks, Jeff. Have a great day.
Thanks, everybody.